Hi, my name is Kyle, and I will be explaining and then demonstrating the geometric, aka computer vision approach for detecting arrow direction for assignment 2 by group 6. This implementation involves real-time video processing using OpenCV, detecting arrow patterns using contour and shape analysis, and classifying arrow directions. This program is structured into multiple functions, each handling a specific part of the detection pipeline, so let's go through them step by step. So for step 1, the first function here, we have pre-process frame, which prepares each frame for further processing. That's it. Next, we have ordering points in the order points function, which ensures that the detected quadrilateral, aka the possible error marker, is ordered correctly before applying a perspective transformation. Next, in step 3, we have get arrow ROI, which identifies and extracts the potential error marker region from the pre-processed image. Let's go through that slowly. Next, in step 4, we have the recognize arrow function, which analyzes the extracted arrow region and determines its direction using shape properties and centroid displacement, which can be seen down here in these if statements. And then lastly, for step 5, we have the track arrows CV function, which integrates all the previous steps to process frames in real time and then display the results. So I'll do a quick demonstration now. So if I take, for example, a forward arrow and show it to the camera, it detects it as forward, as you can see there. If I take a left-facing arrow and adjust it accordingly, it'll flash left. And then if I take a right arrow and also adjust it accordingly, it should also show right. Right about there. And that's it. Thank you.
Hello. Welcome to the machine learning portion of the video. I'm just going to be going over what methods we use for our project, and then I'll be doing a live demonstration. First of all, the methods that we do use are very similar between the two sections. The first one is the pre-process frame method, which just helps to process the frame and is later used in the track arrows machine learning method. And these are the only two methods that we needed to use because of the very ample tools that are provided by the YOLO machine learning system. So with the pre-processed frame section, we just have resizing the frame, converting it to grayscale, applying a Gaussian blur, and doing some canny edge detection to enable for a more accurate detection of any classification. Then scrolling all the way down to the machine learning section, we have the path for the dataset and the model name, and the path for the dataset and for the model. These are both optional, but if the dataset isn't set to something, then it will just default to the I believe it's the Coco 3 or 4 dataset, which is not what we would like to use for our models. And if there is no model name given, then it will train a brand new model with a set of parameters here that have been tinkered with to create an somewhat optimal output. And then much like the computer vision section, it goes through and gets the camera and analyzes what is on the camera in order to give an accurate representation of the items that are on the screen. So now I'm going to begin the live demonstration. And to note, there may be a small cut here just because they're hold on. I can cut there. I'm now going to begin the demonstration portion of the machine learning section. So we're just going to go and start the program with our preloaded data model. And I am going to pull up an arrow. And as you can see, there are still some problems with the arrow not being properly detected 100% of the time, and it misclassifying shadows. As you can see in the background, there is no arrows apparently on the wall, but it has a very strong desire to classify them anyway. So even when holding the forward arrow that it seems to be claiming, it doesn't want to detect it, and these are just some issues that we had run into. And in order to have a high accuracy and confidence, the amount of times that it actually classifies an arrow had to sadly be drastically reduced.